Good morning, my YouTube viewers. Crystal here. I'm here this morning to give you another video on data science. What I'm done is if you go into my GitHub account and you can look under miscellaneous predictions, you can call up the file statsmodels.ipynb and you can follow along with me if you want. What I've done is I've typed in a previous video that I did on an anonymous training deficiency file, and I put that on stats models because I believed that because stats models is more complicated, it's more difficult for me personally to look at, that it would mean that it would give me a better result. And I got some very surprising results. And because of the very surprising results that I got, it means that I'm going to have to go do some more research. So this is what we've got on stats models. The problem statement for this data that I personally collected over definitely a 4.5-year period was training deficiencies for an anonymous department in an organization have been collected from 2016 to 2020. It's worth noting that COVID-19 pandemic started in early 2020, and this would have an effect on the training deficiencies. The task is to analyze this data and look for trends. So the first thing I was loaded the libraries that I need. And the next thing I did was I loaded up the file that I would need. So you can see that this is the file, the CSV file. The file is actually in this directory, miscellaneous predictions. So you find this file and download it if you want to. If you want to use it because it's done anonymously, and I haven't revealed any personal information. I just revealed the month and year and the actual training deficiency. There was no personal information in there. I didn't even say what it was from. See, it's 53 months that I collected myself. So now what we've done is we've made a copy of the data sets. And now what we do is we define our index. So our index starts at 0 and stops at 53 and has one step. Now we convert our month year column to month and year. So month equals train, month year as type string. You have to convert it to a string. Train month equals month string colon -3. So that means we're going to take out the first 3 characters of this string. And so you can see that the month is the first 3 characters of the string have been taken out. So next thing we do is we have to convert the months to numerical values. So what we've done is we've created a dictionary with all of the months have been assigned a number. And we have mapped this dictionary on train.month. And now you can look at train and you can see now that the months are numbers instead of strings. So now what we've done is we converted train month here is as type string. So we added 20 to the year, and then we go to the number 4 onwards. So rather than being 16, it's now 2016, or 17, it's 2017, until you get all the way up to 2020. And so if you look at the train file, see that our year, instead of being 2 digits, it's now 4. So now what we're doing is we're graphing the data. So we're taking a very elaborate data from Matplotlib, and we graph the data. And then when we graph the data on the previous program that I did on this file, we graphed it the same way, but it wasn't as elaborate. But having said it, now we have labels, so you can see that says right there passenger count. It shouldn't be passenger count, it should be training deficiency, but anyway, that's done, and it should be 10 years. So now what we do is we set up TS equals DF training deficiency. So now we've got TS, and we set up DF. This is our data frame DF, and the DF is the same as the train file pretty much, only it's in a data frame now. So we've done another plot, and it says we've got our training deficiency on a time series. So you can see that, and that's pretty much the same graph plot that we had in the last program, the last video that I made, just using a different format. But you can see that you've got hit labels on this one, which is good. And then so now we've done a group by with the year and the training deficiency, and so you can see that our training deficiencies have increased in 2020, and the reason for that is because they've had the COVID-19, and because of COVID-19 they haven't been able to carry out their training. So now what we do is they have the training deficiencies on a month-by-month basis, and you can see how every month what the training deficiencies look like. And so it looks to me like May and June you have the highest level of training deficiencies. Now we created a temporary file, and on this temporary file we plotted it again, and it's still got the same plot because it's just one line of data, but it is you do have labels, which is good, so you can label it. So now we use our basic modeling techniques. So we drop the ID number from train file. So now we no longer have an ID number on the train file. Year is a string, train month is a string, and train date time equals 28 plus train month plus train year, and then train. So you can see that what I did was I added a date to the date, added a date to the month and year, and the reason why I did that was so I could do date time, and I just used the 28th of the month, and the reason why is because this data is collected, this data is produced at the end of the month, and so since in February you have 28 days, I decided that it would be on the 28th of every month that the data would be collected, or so that's why we use 20, because there's 20 just to make it simple. It's in real life, I don't know exactly what day it is that I get the information. It could be a few days before the 28th or a few days after the 28th, but just for this exercise I made everything the 28th because it's the end of every month. So we do a timestamp. Create train timestamp equals PD to date time, train date time format, day, month, year, and train index train timestamp, and then monthly equals train resample month mean train. So what happens is that resamples it every the timestamp is a different format than the date time. So we have another little plot. The plot looks exactly the same as before. So the next thing we do is do another program, say train.timestamp equals PD to date time, train date time format, day, month, year, train index equals train timestamp, and then train equals train resample M. That means monthly mean train. So you can see that the resamples are done on a monthly basis, so you can see what the value is every month using the timestamp. Now what we've done is we've set our training data set and our validation data set, because we're going to break the data set into two. So the training data set is 30 June 2016 to 31 December 2019, and the validation set is 31 January 2020 to 31 October 2020. So now you can see what the train file, and you can see what the validation set is. So now what we do is we make a little graph. So training deficiency, and we plot that for the train, and then we also add the validation file and we plot that for valid, and then it gives us labels as well. But it's exactly the same file that we had, exactly the same graph that we had before, but now it's broken down. It's broken down into train and valid, which is our training data set and our valid data set, the valid data set. Now what we do is we use the naive approach, and we chart this under the naive approach, and you can see that your green is your naive forecast, and the naive forecast doesn't do anything. It's just a straight line. And I compared this against the jet stream, which is, I got this model from the jet stream question, and that was a straight line as well. So what we're going to do is we're going to calculate the RMS, that root mean squared, and that's 57.26%. And what you want is you want your root mean squared to be as low as possible. So now we use the moving average, and then we plot that, and you can see that the moving average is just a straight line as well, using 10 observations. And I tried to check the root mean square for that, and for some reason the root mean squared wouldn't work. But I just decided that rather than take that line of code out, I would leave the line of code in, because I know that it worked on the jetliner data set, but for some reason it's just not working on this data set. And the next thing we do is we're going to do simple exponential moving. And again, it's just a straight line under simple exponential moving. So we have root mean square of 49.09%, which is lower than the previous root mean squared of 57.26%. So we do some more graphing so you can see what the graphs look like. We've got residual, seasonal, trend, and observed. Now we have Holt's linear model. And on Holt's linear model, you'll see it's just a straight line again. and calculate our root mean squared, which is 34.52%. You can see the timestamp on that. This tells you the predicted values. We can check the shape of the valid training deficiency and y-hat average whole linear shape. And we can compare these values against the predicted values. And that's that, because we didn't have a test file. We only had a training file that we broke down into a training and validation data sets. I'm not able to use this model on any test file. But it was still very interesting, the results that we got, because when we put the model on the validation data set, which is called valid, we got a root mean squared of 34.52%. But what I would like to do, just to do a check, I put the root mean squared program on my previous program, and I had an error of 23.29%. So on the previous program, which was I was just using polynomial features, I had a lower root mean squared. So what that says is the error that you got using polynomial squares was less than error that you got a whole linear model. So what that tells me is that I have to take the data sets for the jetliner and put that into the model that I made and check that out and see if I can get a better accuracy using polynomial features. So that's the next task that I have to do. So that concludes it for this video. You're more than my data set for your own to. It's a mess, and I haven't information. And thank you so much for watching my video. If you like my video, please like, subscribe, and share. If you like the work I'm doing, please, and you want to make a donation, I've got my email address for the donation for my PayPal account. The thing is I don't have enough subscribers to monetize, which is why I have to ask for donations. But let me know what you think about this video. And thank you so much for watching my video, and I look forward to making more videos for you.